Good day to all. Today we are going to see about that synchronous motor. This is the overall view of that synchronous motor. Here is a exciter and a slip rings. Here stator and the rotor. See, synchronous motor. What is that synchronous motor? It is electrically identical with an alternator or AC generator. A given alternator or a synchronous machine can be used as a motor when driven electrically. Some characteristics features of the synchronous motor are as follows here. It runs either in synchronous speed or not at all. That is, while running it maintains a constant speed. The only way to change its speed is vary to supply the frequency, because Ns equal to 120 F by P. It is not inherently self-starting, that is the main thing. Then it has to be run up to synchronous or near synchronous speed by some means before it can be synchronized to the supply. See, it has a capable of being operated under a wide range of form factors, both lagging and leading. Hence, it can be used for a power correction purpose in addition to supplying a torque to drive the loads. Then the principle and the operations of that single phase induction motor. Now you will see over here. Here it is two magnet, which one is north and another one is south, north and south pole. Here the three phase supply is given to here, and when a three phase winding is fed by a three phase supply, then a magnetic flux of a constant magnetic but rotating at a synchronous speed is produced. See, when we are giving a three phase winding is fed by a three phase supply, then a magnetic flux or constant magnetic but the rotating at a synchronous speed is produced. Now we will consider this two pole stator in this figure, in which are shown the two stator poles, here marked as Ns and Ss. It is rotating at a synchronous speed. We can say in clockwise. You will see this is in clockwise direction. Since the two similar poles, N, which means a rotor, and Ns stator, as well as S and S will repel each other. Why? You will see here this N is rotate this anti-clockwise, and this Ns will rotate clockwise. N of rotor and Ns stator will have a opposite directions. So the rotor tends to rotate in anti-clockwise direction. But a half period later, stator poles having rotated around interchange their position. That is, Ns at position at B and this Ss at position at A. The thing is, see, now this Ns position, this stator position is in here A. But after some time, this Ns position will come over here. This Ns position come over here in B, and this Ss position will go to that here, this in that A. So it will come like this Ss position. So at this condition, Ns attract S, because this is not a opposite direction. So this Ns will attract it with the S if it is the Ns over here, as well as this Ss. If the Ss is come over here, this Ss will attract the N, because this is the north one and that one is the south one. Then the rotor tends to rotate clockwise. Hence, we find out that due to continuous and rapid rotation of stator poles, the rotor is subject to torque, which tends to move it first and in one direction and then in opposite direction. Then, owing to its large inertia, the rotor cannot instantly respond to such a quickly reversing torque, with the result that it means a stationary one. Then see now the consider the figure shown in 3.6a, where the stator and rotor poles are attracted each other. As I said before, this SS will come here in that A position and this NS will come here in that B position. Now it's in attracts towards each other and it will have a clockwise rotation over here, right? Likewise, suppose the rotor is not a stationary but it is rotating clockwise with such a speed that turns through one pole pitch by the time the stator poles interchange the position as shown in figure B. The thing is, if the rotor is not stationary, see here, the rotor is not stationary but it is in rotating clockwise with such a speed that turns through the one pole pitch by the time the stator poles interchange their position. Here you can see the stator is interchange the position again. Here again the stator and the rotor poles are attracted to each other. They will try to attract each other. Why this stator will come again? Because of with the speed turns through the one pole pitch by the time of stator. As we said, the stator is not stationary. So again this will attract each other. It means if the rotor poles also shift their position along with the stator poles, then they will continuously experience the unidirectional torque, which means the clockwise torque as shown in figure 36.3. See, if the rotor is also rotated, then it will get the continuous rotation over here. Then there are two methods of starting in here in that synchronous motor, but we are going to see about this auxiliary drive and induction start. This auxiliary drive is a induction motor or DC motor. Then the induction start is using a damper winding like that. Now the general starting procedure, the rotor which is S2 unexcited is speed up to the synchronous motor or near synchronous speed by some arrangement and then excited by the DC source. The movement is near synchronously rotating to the rotor excited, then it is magnetically locked into position with the stator. That is, the rotor poles are engaged with the stator poles and both run synchronously in the same direction. Because this interlocking with the stator and the rotor poles, that the motor has either run synchronously or not at all. The main thing, however, it is important to understand that the arrangement between the stator and rotor poles not absolutely rigid one. As a load on the motor is increases, then the rotor progressively tends to fall back in the phase, but not in a speed as DC motors. So by some angle 36.4, but still continuous to run synchronously. The value of this load angle or coupling angle, as it is called, depends on the amount of load to be made by the motor In other words, we can say the torque developed by the motor depends on this angle, say alpha. Then this angle referred to load angle or coupling angle, and this is also angle between the rotor and stator poles. These are all about this motors. Thank you.